Welcome back for part 2 of integer exponents. Today we're going to apply the properties of integer exponents. We already know that when we're using order of operations that we try to do inside grouping symbols first, then we do exponents, and then we multiply, divide, add, or subtract. And so we're going to apply that information along with the rules that we just learned about integer exponents. So our first example here is 5 minus 2 to the 5th power minus 3 to the negative 8th power plus, inside parentheses, 5 plus 2 to the 0 power. And with the order of operations, we always do inside grouping symbols first. So 5 minus 2 is 3, and 5 plus 2 is 7. So now I look at the exponents. And we all know that automatically that anything to the exponent of 0 or power of 0 is always going to be 1. So that's where this 1 comes from. And then we look at the 3 to the 5th power times 3 to the negative 8th power, and we notice that both bases are 3. Because it's multiplication with same base, we know that we can add our exponents. So we're going to take 5 plus negative 8, and that's going to give us negative 3. So our expression now is 3 to the negative 3rd power plus 1. Well, remember when we had a variable to the negative power, let's do negative 2. What we want to do is to create the reciprocal of the base, and then the negative exponent becomes a positive exponent. Okay? So if I have 3 to the negative 3rd, I want to reciprocal the base, so that means 3 becomes 1/3, and the negative 3 exponent becomes a positive 3 exponent. And we know that 1/3 times 1/3 times 1/3, 3 times 3 times 3 is 27. 1 times 1 times 1 is 1, and so 3 to the negative 3rd becomes 1 over 27, and that's where this came from. We're going to take 1/27 and add 1 to it, so we get a total of 1 and 1/27. When I look at this example, it's a division problem, but there's also grouping symbols. So inside this grouping symbol, we have 3 plus 1, and that's 4. So we have 4 to the 2nd power to the 3rd power. And then below here, we have 7 minus 3 to the 2nd power. So 7 minus 3 is 4 to the 2nd power. I see that I have a power to a power. So I'm going to take my 4 to the 2nd power to the 3rd power. And 2 times 3 is 6. So that's going to be 4 to the 6th power over 4 to the 2nd power. And remember, with division, we're going to subtract our exponents. So we get our base is 4 to the 6 minus 2 power, which is 4. So we're going to get 4 to the 4th power, which equals 256. So let's practice a couple. So if we look at number 6, we have a division problem. We have grouping symbols, and we have a power to a power. So we're going to start with our grouping. What would we do first? Right, we're going to subtract 6 minus 1, and that's going to give me 5 to the 5th power, or to the 2nd power, to the 2nd power, over 3 plus 2 is 5 to the 3rd power. Now 5 to the 2nd power to the 2nd power, those are going to be multiplied, so 2 times 2 is 4, over 5 to the 3rd power. Now this is division, so we're going to subtract our exponents. So we're going to take 5, and 4 minus 3 is 1. So we're going to have our final answer is 5. On number 7, I have 2 to the 2nd power to the 3rd power minus 10 minus 6 to the 3rd power times 4 to the negative 5th power. And the first thing I want to do is, if I can, simplify anything inside expression. So I have 10 minus 6, that's 4. So I'm going to bring everything else down. Minus 4 to the third power times 4 to the negative fifth power. And something I'm noticing is that this is a base of 4, this is a base of 4, and this could be a base of 4 because 2 squared is 4. So we have 4 to the third power minus 4 to the third power times 4 to the negative fifth power. Okay? So when I'm working these through, I always try to do multiplication first. And when I see that, I see this multiplication right here. So this base and this base are the same. 3 minus 5 is negative 2. And I get this. When I'm looking at this, I see that I have 4 to the third power minus 4 to the negative second power. And this is telling me that I need to reciprocal my base to make this a positive exponent. So then I'm going to have 4 to the third power minus 1/4, and negative 2 becomes positive 2. This leaves us pretty much in where we just need to convert to standard form from exponent form. And what we're going to do is 4 to the third power is 64 minus 1 and 4 to the second power is 16. So I'm going to have 64 minus 1/16. I like to stack mine because I'm going to need to do some regrouping. Now, 64 is a whole number and 1/16 is a fraction. And remembering the rules from fractions, 64 would be the same as 63 and 16 over 16. The reason I chose 16 over 16 to represent my 1, because 63 plus 1 is 64. It's the same number, just rewritten, is because I had an exponent or a denominator already of 16 from this exponent. So I chose 16 over 16 to represent my 1 so that I can easily do my math. So 16 minus 1 is 15, and my denominator still remains 16, and I bring down my 63. So my solution to number 7 is 63 and 15/16. So 63 and 15/16 is my answer for number 17. If you have any questions, make sure you talk to your teacher.